Bueno, agradecerles que vinieron, agradecer a la facultad que nos dio este espacio para recibir al profesor Danny Dig, que es de la Universidad de Colorado, que nos va a hablar de las cosas que están haciendo con LLMs y ingeniería de software. Con Dani nos conocemos desde hace más de 20 años, que éramos alumnos de doctorado en la Universidad de Illinois en Urbana-Champaign, con Ralph Johnson como director, en el momento que se estaba gestando el refactoring, ¿no? Y se estaba haciendo importante. Y lo más destacado de Dani era el entusiasmo que él tenía por difundir lo que estábamos haciendo en el grupo, ¿no? Que tenía que ver con avanzar la ciencia, pero no solo eso, no solo escribir papers científicos, sino también construir herramientas útiles para desarrolladores, ¿no? Y así es como después en su carrera ha construido herramientas muy importantes, muy utilizadas, como Refactoring Miner, que es muy utilizada para, por ejemplo, de una versión a otra de código, con un 99.9% de precisión puede decir qué refactoring se aplicaron de una versión a la otra. Y bueno, y ahora nos va a contar de las herramientas tan potentes que están desarrollando. So, thank you so much for coming. This is a pleasure to have you here. So,
Es un placer. Muchas gracias. Un placer conocerte. And I've just used half of my Spanish words, so I'm just switching to English now. Thank you so much for the wonderful introduction, Ale. It's such a joy to come back and see Ale and Federico, and to see all of you. So I've been in your beautiful country of Argentina for 1 week. I came here with the Maxwell Leadership Foundation and with a local non-profit from Argentina called Argenova. We've been doing soft skills and leadership training for 5,000 leaders in your country. So we've been working with leaders from government, from education, from universities, from hospitals, was training CEOs and leaders in software companies, in other businesses, in non-profits. We work with some of the homeless shelters, leaders all over the country. And what really amazed me, spending 1 week with your beautiful people in this program called Transformación Argentina, is how much your people, what's the warm heart that they have, how they want to, what's best for their community, for their family, for their country. And this is why I'm so excited about the future of Argentina, because of the people. You are the ones, the future is not the politicians, the future is you, the people, who grow yourself. I understand that this is almost the end of the semester, so students are very busy now with preparing for projects. We are very busy doing turning all the assignments. Yet you're still here because you want to learn, you want to get better. So this is why Argentina has a bright future, because of people like you that have a good heart and you live good values and you learn about how to live good values. So Alejandra, as she mentioned, I've known her for Alejandra and Federico. We were colleagues together, known her for more than 20 years now. And I know she studies and she does research in computer science, but I think she also does something here that she hasn't shared with you. Like when I saw her today, and I just sent a picture, took a selfie, sent a picture to my wife. My wife also knows Federica and Alejandra. My wife, and both me and my wife said that Alejandra hasn't changed at all in 20 years, so I think she secretly studies the science about freezing the time. So she hasn't yet, she still has to study how to go back in time, how to go travel in time. She hasn't discovered that yet. But she discovered how to freeze the time. So if you want to learn about that, I think that's a secret lab. She has the LIFIA, the official lab, and she has the secret science. I've been so much enjoying getting to know the people of Argentina, but they also introduced me to the amazing foods of Argentina. So I got to love dulce de leche, alfajores, and the amazing meats and the steaks. So I even got a poster showing it shows all the meats and all the steaks in Argentina. So I know there's a lot of rivalry between Brazil and Argentina, who makes the biggest, the best steaks. And after being here in the country for 1 week, I can tell you Argentina 1, Brazil 0. Ole, ole, ole. Argentina does better steaks. I enjoy all the meats. Beef del chorizo was one of the favorites that I really enjoyed. So Alejandra asked me, what am I going to do with this? And I said, I'll put it in my bedroom, so when I go to sleep, last thing before I fall asleep, I'll look at this one more time. And hopefully that will help me dream at night about all these amazing steaks that you have here in Argentina. So, we are here to discuss about how generative AI is not going to replace programmers, but is going to make programmers better. And I will bring several examples from the work that I've been doing when I was on a long sabbatical for 2.5 years at JetBrains. I don't know if anyone is using the JetBrains IDs, IntelliJ or PyCharm, and anyone uses any of those? Okay, see some hands. What are you using? Both IntelliJ. PyCharm, okay. Okay. Anyone else uses IntelliJ or PyCharm? Okay. What are you using? IntelliJ, okay, good. So I was for 2.5 years with JetBrains, so this is the leading companies for integrated development environments, and we've done a lot of, in fact, all of my work at IntelliJ, at JetBrains, was in the area of generative AI. So today I want to bring lots of examples from that area, but also I'm going to bring examples from my research group, what my PhD students are doing to advance the field. And someone was saying, one of my mentors said something really nice. He said, AI is going to make smart people smarter, so that's good, but AI is going to make lazy people even lazier. So I hope that you are in the first category, and that's why you are here. You are already smart, you want to become smarter. I think the danger is with AI that we can stop thinking and just go and ask AI to answer and to solve any problems for us, and actually can solve very well many assignments. So we have seen many times that software students, they can turn in perfect homeworks. If you look at all their homeworks, they get perfect grades, yet they fail the final exam. Why? Because those are the students who don't use AI to make them smarter, they use AI to make them lazier, because they stop thinking. So what they want to show, it's a different way of using AI that will still engage, they will still keep the programmer in the driver's seat, you will still keep your thinking skills, and we use AI to augment what we are, so that we can do more, we can do better, we can reason faster, we can think about a wider variety of variants of programs and designs, and then we have the time to do on our own, and we use AI to make us smarter and better. Who wants to learn about this? Anyone? Okay, well, we are ready to start. So before I do that, let me share this picture. So I've noticed that here in La Plata is very beautiful to ride bicycles, but it's very, very flat. So this is perfect for riding bicycles. So they even have horses here. So bicycle and horses, this is very nice for that. Where I live at the base of a canyon, so I have to go up the mountain. So when I ride my bicycle, this is a typical ride for me. Don't know if you can read very well, but in this particular ride, my distance was just less than 8 kilometers one way, but I was going steep. The canyons are about 800 meters elevation gain, so just below 1,000 meter elevation gain. Now, if you look at my body, by no stretch of imagination, I don't look like one of the famous bicycle racists. I do not race bicycles. In fact, I need to turn from the side so you can see very well. I have a nice surrounding. You can see there's a lot of dulce de leche here, alfajores, and beef del chorizo. That's what I like. Okay, and now I was going on this steep canyon up the mountain, and there were other people who looked very solid, who looked like they're professional bicyclists. And I was passing them and smiling and saying, I have a great time, I enjoy going up the mountain. And they were working too hard for them to respond to me. But how did I do it? So I have an electric bicycle. So this is 500 watt-hour battery, so it's enough to help me get all the way up the mountain. Now, let me tell you, this is not a motorcycle. So the moment when I stop pedaling, the bicycle stops. But how much I pedal, how much effort I put, that it matches and gives me back. So when I go, I don't have to use it when I go flat, but when I go up on a steep road, that's when I love to have this. And when I go with this electric bicycle, looks like I have this guy behind me, he's pushing all the pedals along with me, so me and my body, we can go up the mountain and we have a great time. The only reason why I go up the mountain is so I can go down. I don't like to go up the mountain, I like to come down fast, and I like that feeling. So for me, that's the only reason to go up the mountain, so that you can come down the mountain. So that's why I want to have a system. Now, I want to make the case that generative AI is the equivalent of this assistant. It's not going to replace us. Again, it's not a motorcycle, it's not a car, it's still a bicycle. I still tell where to go. I'm still the one involved and giving the input and saying, okay, this is how much assistance I want, this is how little assistance I want. So I'm fully in control of this. This is not a self-driving car, it's not a self-driving bicycle. But the assistant helps me, and it's the same thing with generative AI. So I was at the wonderful keynote very recently by Elizabeth Georgi. She's the director of user experience at Google. And based on the research science they've done with tens of thousands of programmers, they found that these are the 9 hardest things that programmers have to do. Yet now, if you look at them, none of them is rocket science. Writing test cases, okay, now everyone can do it, right? Doesn't require a PhD in software engineering. Everyone can write test cases. Do people like to write test cases? I haven't met yet any programmers who say, oh, I can't wait in the morning, I'm going to wake up and write 12 or 29 test cases today. But, so it's hard in the sense that people don't like to. Writing documentation is the same thing. Like everybody can write documentation. If you can speak to people, you can write documentation. Do people love to write documentation? Again, I haven't met yet those programs. Maybe they exist. Maybe I haven't met everyone in Argentina yet. But the ones that I know, don't know programmers who are excited, oh, I can't wait today, I'm going to work, I'm going to build a company, or I'm going to work on this open source project, and today I will write this amazing documentation. Like everything here, like implementing code that somebody else wrote, working and reading on somebody else's code, look at the last one, estimating and naming things, giving names to things. This is not rocket science, coming up with good names. For software, for program elements, again, this is not rocket science, but people don't do a good job. So I want to say this is exactly the 9 hills that when I go up the hill, this is what I want to have on the system to help me with. So I will give several examples, and this is some numbers I got from Amazon, so from their assistant, from a programming assistant powered by AI. They've done the science that shows that people who use this Gen AI power features are 57% faster than those who don't use them. And again, this doesn't surprise me, but what's even more interesting is that 27% of the people who use this are much more likely to finish the task, to complete the task. Like we all know, we start doing some coding, it gets hard, we get discouraged, we give up. Maybe some students start taking some classes, maybe you were excited about the class, you start working on some of the programming assignments, and then kind of you will start seeing, oh, this is harder, and then you lose interest, and then you drop the class, and you don't even show the final exam. So this is what I'm the most excited about, this number, that with the help of generative AI, it can help you get unstuck so you can make progress. Right? This is a completely new paradigm of writing software, where AI, again, as I said, is not going to replace programmers. AI is going to help us to go over those hills. It's going to help us do the things that we don't always love to do, but we can still be in the driver's seat and we can use AI to do those things. So for the rest of the talk, I'm going to use some examples from JetBrains. And here's the first one I want to use. AI helps to explain code, especially when something breaks in the program. So in this particular example, I'm going to show how there is an error, stack trace, and AI is going to help the programmer to figure out what's the root cause of that error. So the research shows that people spend more time reading code than reading, especially in somebody else's code or reading their own code, than writing code. So here's an example where, I don't know if you can see, but there is a loop here. There is a loop that iterates over elements, and there is an infinite loop. So this is probably a novice programmer, they wrote this code, and this program crashes, it iterates over elements. It's a Java program, it keeps iterating and generating more numbers until it eventually runs out of heap space. So the program will crash here, oops, going back. The program will crash and will generate, here it's out of memory exception. So now you can come here and say, explain with AI, then he will tell you the reason why this code crashes is because it is an infinite loop, and it tells you here on the right side, maybe a way to move forward is to break this infinite loop. So this loop terminates, and maybe it tells you here is a stop condition that you need to insert in this loop. Right now, if you look at this, will it replace teaching assistants in our classes? Absolutely no. Right? But if students who get stuck, they can use these features so that it helps them to move forward, and they only go to teaching assistants with other problems that they haven't had any chance to understand yet, or that with AI they were not able to still move forward. They will dramatically reduce the burden on our teaching assistants. Right, let's look at another one. AI suggests names. So this was on the list of the 900 things from Google. This was the number 9. Now, again, it's not rocket science. People can write, programmers can write good names. They don't like to write good names. So have you, if you remember, there is a quote from Shakespeare. Like he said that which we call a rose, by any other name should not just as fine. So what he wanted to say is it doesn't matter if you call this a rose, I call it a smelling flower, a pink flower, it doesn't matter, if we can still understand, we can still figure out. But I want to tell you, if Shakespeare was living today, I would have a meeting with him, I would have mate with him and say, hey, let's sit down and let's have mate and let's talk about some things. I know that you are famous for saying what's in a name, and well, I want to tell you now, again, you're just friendly, and I will invite him back and maybe have a bit of chorizo so he doesn't get angry at me. But I will tell him you're wrong. When it comes to programming, names are very important. So, why are names important? Because if you wrote this one letter, or I don't want to say 4-letter word, those are bad. You already know the 4-letter word is bad. If you like 1-letter word, is the equivalent of using 4-letter. My children, I have teens, so don't use 4-letter words, right? Because 4 letters are bad. But in programming, if you use excessively, if you use a 1-letter word, it's as bad as a 4-letter word. So here's some code that maybe someone who was in a hurry wrote that has a lot of these 1-letter words. And using AI as an assistant, it figures out, what this thing is doing. It's calculating, these are all coordinates, it's calculating the orientation of this figure. So then it suggests to rename the name of this. This is a function that calculates coordinates, and we are going to name it from T, a 1-letter word, to a full name that is conveying a meaning to the programmer. So someone else who comes after you, like they can just read the name and say, this is actually what this code is going to do. All right, so let's look at a couple more examples. So many times programmers have to repeat the same changes all over the code. So here's an example where, mixing up these two buttons. So here's an example where it's a class that it's some business class that has to do with some messages. And here in the console, the programmer is going to type, add some functionality to persist this to a database, to a SQL, so all the messages in my application, I want to persist those in a SQL database. So now what the tool is going to do, this is the AI assistant from JetBrains IntelliJ, is going to look in your code base, all the code that deals with messages. It will add the SQL, the persistent storage mechanism, so you have a persistent messages stored, let's say, in a SQL database. Right, so everyone is excited about agents. So the JetBrains agent offering is called Junie. Anyone has ever used Junie so far? like probably use other agents from other programming environments, Cloud Code or Cursor or Copilot. It's the same workflow. You can say, help me, here is some design documents, here is some ideas that I have in mind. Draft for me the first implementation, the first sketch of the program. So in this case, someone says, I want to write an application that uses some computer graphics, computer vision library to track and count some objects in a sports facility, to track and count certain movements. Right, so this is going to generate some code, some initial skeleton, some test cases of how to use that particular libraries. And then you can actually even interact with it. So it has the generation part, but also has the interaction where you say, use this particular library or use this other library. I want to make sure that we achieve this particular design or that particular design quality. So you can actually interact with it and you can ask questions and you can respond to your questions. Right, so that concludes the first part of my talk. You can see how we're doing it now. Okay, we're doing good. Where I showed some of the examples of features that are already present in programming environment that we use today. If you want to try this, everything that I've shown, you have a free educational license because you are running a university, so students, faculty, all can get a free education license for all the IntelliJ products. And even for the ones who are powered by AI, they give you a certain number of credits. I don't exactly remember how many credits you get, but all these AI features you can test and you can use them and provide you a certain number of credits, after which you will have to supply around API tokens. Let me switch to the second part of my talk where I want to take you on a journey about what's the frontier, what's the avant-garde, what's upcoming, what is the new exciting research that is not yet. You're not going to find it today in IntelliJ, but if you wait another year or two, or maybe 3 years down the road, you're going to see these features coming into the development environment. So this is more the avant-garde, the frontier, the forward research that we are doing. And in this part of the talk, I want to show how we are turning to generative AI. Some people are saying, well, will it replace my research? If AI can do whatever I was researching, if AI can do as well as I do, then what's the role of master students and PhD students and researchers? Why we should do research when AI can do everything that we are doing? And I want to tell you that's not the case. There are lots of errors that AI can make. We call those hallucinations. These are errors that are so subtle. If you look at the AI solution, it looks deceptively, it looks almost perfect, except has a deep flaw in it. We call it a hallucination. So I'm showing several examples of hallucinations that AI generates, and this is where we cannot delegate simply all the work to AI. This is where we need to use other tools, other validators, and in this case I'm going to show how we use the validators, the static analysis, and the IDs to compensate and to filter and to remove those hallucinations. So, Together We Are Better, this is a paper that we just presented 3 weeks ago, if my memory is right, if I can still count, 3 weeks ago in New Zealand. I was there to present this at the International Conference on Software Maintenance and Evolution. I don't know how many of you got the chance to travel there, but don't worry, you don't have to travel to New Zealand. I figured out how to take you back in time. So Alejandra figured out how to freeze the time. I figured out how to, in a very small niche case, I figured out how to go back in time. So I'm going to go back in time 3 weeks ago to New Zealand and take you, the audience, bring you invite in New Zealand so you can actually see a presentation that you see the presentation at the conference. So lots of people work on this. It's an amazing team. So when you heard the word teamwork makes the dream work. Have you heard this saying? Teamwork makes the dream work. I don't know how to say it in Spanish, but how do you say it in Spanish? Teamwork makes the dream work?
Trabajo en equipo.
Trabajo en equipo.
Lo hace mejor.
Es mejor.
Es mejor. Sí.
Tres mejor, okay. Trabajo en equipo es tres mejor. This is an amazing team we've had from the leading students are my PhD students, and we had collaborators from other universities, from Tulane University, from University of Texas, from Concordia University in Canada, If you notice, there's something missing here. We don't have any collaborators from Argentina, from Universidad Nacional de La Plata. So next time, I hope that when I come and present the paper at the conference, the other will say, okay, this is something interesting, this is something that is exciting for me, something that you have something in common, and I would love to collaborate with you so that we can actually invent and do science together. We also have collaborators from industry here, so several companies, so of course JetBrains. This is the work I've done when I was at JetBrains, and we have a couple of other interesting collaborators with us, with Amazon and NBC. Right, so this is using generative AI. It's a specific example of research that uses generative AI to advance the field of refactoring, and in this case, it's one particular refactoring, it's a move method refactoring. So why do we work on move method? It's one of the top 5 most common refactorings that programmers do in practice. It's very well supported by the IDs. It's very well studied. It's very well practiced. It's a very common refactoring because it improves cohesion of the methods, of the fields, of the state of the class, and reduces the coupling. Right? So it's very famous for reducing these technical, we call them code smells. It's not that code doesn't have a smell. Like you smell it, and it's not, oh, this code smells like poop, or this code smells like animal. No, there is no smell in the code. We call it a code smell because there is something in the design that is not right about this code. So for someone who's a trained, experienced expert designer, say there is a bad smell in the code. One of them is called God class, where you have a class that is so large and does everything. Maybe you haven't wrote that kind of code, maybe you've seen the colleagues. So maybe if you turn to the person next to your left, maybe you yourself, you write very good class, but I'm very worried the person next to your left. Okay, so I know that you write very good, but if you turn to the person next to your left, then I'm not so sure. Maybe that person writes some of these God classes, which is very large. Almost all the functionality of the code is in one single class. And maybe a couple of classes that have a lot of code, very large methods. So it's called the God class because it tries to do too much, it tries to do everything. That's a bad design principle. Another bad design principle is feature envy. So here we have some kids who want to go to the pool, so there's a bed and they cannot go to the swimming pool. So the equivalent is here are some methods in a class. But these methods in the class, they are not operating on internal data from that particular class or state from that class. They only operate on data and state and methods from other classes. They are more envious. They say, oh, I wish it would be on the other side of the fence. You have the sentence that the grass is always greener on the other side. Right? So in this case, the water is always bluer on the other side where we have the swimming pool. So that's the equivalent of a feature envy. So move method, it's a famous refactoring that eliminates these code smells from code. So here is some example from Elasticsearch. This is a famous open source project. This top class SQL session has a lot of methods and also this method called resolve policy. Now this method, if you look, it doesn't use any of the data here. It operates over this class policy resolver. Right? There is a field for policy resolver, and all that this method does, it executes, it iterates over elements of this class and it invokes methods from this class. So programmers realize that this method doesn't want to be in the SQL session class, wants to be in the policy resolver, so do it in practice. Now, this is very well supported in IDs. So here is, I'm showing the screenshot from how IntelliJ implements this, IntelliJ IDEA. It's very nice. Unfortunately, it's a semi-automated process, so the ID will not tell you, here are the methods that are misplaced in this particular class, that are foreign in this class, and here is a better target class for those methods. So that's all up to the programmers to figure out and to reason and to search the code, what's a better host, what's a better home for this class. Right, so it's a semi-automated process, there are no automatic recommendations, and this is where there's been a lot of research in this field. So several approaches, they usually fall in 3 large categories. People have used static analysis tools like JMove and JDeodorant are famous tools. The problem with those is they require developers to come up with certain thresholds, manually specify what are certain cutoffs, what are some outliers in the code, and how do we manually specify those. It's also very slow. Usually they tend to analyze the whole program, have to create a program program, structure for the whole program, dependencies for the whole program. Now, Elasticsearch is a medium-sized project. It's not even one of the ones that we consider large. It's just below 1 million lines of code. It's about 800,000 lines of code. Now, running this tool on a project at this scale will definitely be extremely slow, several hours, or in this case, actually, we couldn't even run it. It runs out of memory. It's poor scalability. So here's another approach, machine learning. So they've been using either the classic machine learning trainers and classifiers, or using deep learning. So the problem with this approach is they constantly need retraining as these programs evolve. You need an extensive amount of training. It overwhelms the user, so they are not looking at this as a recommendation problem. They look at it as a classification problem. So they will tend to provide 60 or 70. They will classify all the methods in this particular class, and will provide all kinds of matching, all kinds of pairings. It will overwhelm the user with many, many recommendations. So now, as a developer, as a user, as a programmer, you have to look at 60 or 70 such recommendations and figure out which one makes sense. So people don't like to do that. So the problems with all of these approaches, they tend to optimize. They look at software quality metrics, coupling, cohesion, certain other program dependencies. They're trying to see how can we move code around, how can we restructure the code so we optimize those qualities. Unfortunately, those recommendations do not align with the way how programmers feel naturally, how we naturally refactor the code. So the idea was, what if it turned out to LLMs? So LLMs are likely, they've been trained on billions of code functions. Like likely they've seen millions and millions of classes, and they've seen what methods go into which classes, right? So we think because they've seen so much code, they've been trained on so much code, that are much more likely to come up with recommendations to tell, okay, this is a foreign in this particular code, in this particular class, this method doesn't belong. It looks like it's foreign. So capture this semantic detail. We think that they should work better, right? And in fact, actually, they do work better. So here I'm revisiting the same example as before. So we're going to run on this, we're going to run these previous approaches and see how well they do. So we are running HMove. This is a deep learning approach. So it recommends to move these methods. Unfortunately, the methods that it recommends to move are not the ones that programmers move. So these are methods that are very native, that feel very at home in this class. It doesn't make sense to move those methods. We ran JMove. It ran for several hours for this class to produce any results, unfortunately. We ran LLM. Now the LLM, we're using the frontier LLM, we're using OpenAI GPT. So it comes with several hallucinations. So first of all, it tells us to move methods that do not make sense to move. They are very native, they are very at home in the current class. It doesn't make sense to move them. It also, when it comes to the methods, fortunately, it also tries to move this model of resolve policy. But the problem with this recommendation, it tells us it comes and hallucinates other classes that don't even exist in the program. Say, well, this resolve policy should be moved to this other class, which doesn't even exist. It just makes up some classes that don't exist in the code. But I say, fortunately, it gives us a good recommendation. But among these good recommendations, there's many other recommendations that don't make any sense, or they are impossible, they are mechanically unfeasible, or it tells us to move things where we don't even have those classes. So we studied this, we ran this on hundreds and thousands of experiments. 80%, up to 80% of the LLM suggestions are what we call hallucinations. So they are invalid, they are either doesn't make sense to move them, or the code is deeply flawed. You could move it, but it will have it will degrade the performance, it will degrade the design, it will not improve the design. And another big problem is the reason why this is such a high rate of hallucination. I showed this is a simple, it looks like a deceptively simple refactoring, but to be good at this refactoring, you need to understand the whole scope of the project. Right? It's one thing to be able to say, here is a method that doesn't belong in this class, thank you, but now tell me where I should move this method. So for an LLM to understand where I should move this method, it needs to understand the whole project. As you are aware, I don't know if you have special LLMs that I don't have access to, but The LLMs that I use have a limited context window of a few thousand tokens or tens of thousands of tokens that keeps growing. But you cannot naively, you can say, here is the whole project, a million lines of code, dump it in the prompt and say, analyze this whole project and tell me where should I put this method that is out of place. Like, even if the context window was so large, which right now we can't do, but even if it was, if it doesn't, it further actually even confuses the LLM. It doesn't have the LLM. There's a lot of research that shows that actually LLM lose focus. The more context that you give, now they are going on all kinds of wrong directions. Right, so that's another key challenge. Another key challenge is how do you fit this into something that is practical, that you don't overwhelm. Same way how deep learning approaches overwhelm the developers. We don't want to use an LLM to come up with many recommendations. And especially we don't want to show recommendations that we know are invalid or hallucinations. Programmers are very quickly going to discard those and are not going to use those technologies. So here's our key ideas. So in order to solve all these problems, we say, what if we combine the insights of the LLM? They've been trained, so they are mimicking what programmers do. So what if we combine those with all the heavy lifting, with all the rigor, with all the precision, with all the analysis, all the correctness that comes from the IDs, all the static analysis from the IDs. So this is how it's key for us to filter hallucinations. We can automatically filter all those 80% of the recommendations that are hallucinations. We show the programmer only the top 20% that are truly going to make a difference in our right. So to actually scale up and grow over large programs, we are going to use, in this case, we are using semantic embeddings where we have a certain way how we first pass the whole program, we get a vector representation, and based on that, we can search what are the appropriate classes, we can pass those to the large language model. So it's called refactoring or retrieval augmented generation. So it's more of a sophisticated way of writing a prompt that we prefetch some of the classes that are more likely to be better candidates for new targets. And what we show to the programmer, it's not more than 3 high-quality recommendations. And our full movement assist is an intelligent plugin that implements all these ideas. So I'm looking at the time, and I have 10 more minutes that I want to open for Q&A. So I'm wondering if I reach here under the table, I find a special stick that I put in another gear. If you have your cars, you drive manual stick car or automatic car, so if people who drive manual, you know, I'm searching for that. And I shift to another gear, so I'm going to go a little bit faster. So probably I'm going to skip how this all works, so you can read it in the paper. Let me just give a couple of small slides on this project. How do we evaluate? How do we make sure that actually this works correctly? We use 2 data sets. One is a synthetic corpus that other people have used previously in the research, so we want to compare apples to apples. We want to compare with other baselines, so we're going to use the same benchmark that they used. And then we created a new benchmark that is uncompromised, where the large language models have never seen, have never been trained on that, so that's a much more fair comparison. So that we can test actually that the data hasn't leaked, the data hasn't, people talk about data leakage, where a large language model will not use its reasoning capabilities, use its memorization capabilities. They will tell you, people who have seen in training, have seen those recommendations, have seen what's the final solution. So we don't want LLM to use its memorization, we want to use its reasoning capabilities, so we create a new benchmark. So we have a concoction of several empirical methods, so formative studies, we've done open source verification of real world refactoring scenarios from open source, we mine repositories, we've done a user study, deploy some questionnaires, some surveys, and we're going to compare against this baseline. These are the best in class in the field of static analysis, deep learning, and classic machine learning, and also we do a user study participants with 30 participants who use this tool for 1 week on their project. So I'm going to move faster. The main method that we're going to compare is a recall at K. So if you show you a small number, no more than 3 recommendations per class, of those 3 recommendations that we show here are methods, and here is the class where I should move. Like in any class, no matter how large is the class, I'm never going to show more than K is 3. Like how many of those match exactly what the programmers end up doing in the open source project? So that's our metric. If we hit it, that's success. We have high recall. So we compare with the previous state of the art. We have 1.7x, and this is not as high, it's not 17%. It's 1.7 times better than all the previous state of the best of the best. Of course, the group is much bigger compared to some of the other baselines which are shown here. But the best of the best, we are doing 1.7 times better than it. LLM alone also performed decently well, but with a very, very high rate of hallucinations. So if you have the patience to go and remove all the hallucinations, eventually the recommendations are going to find the good ones, but at a very high cost. But when we replicated the open source refactorings, this is uncontaminated by LLM training. Now we see an even bigger increase over the previous best in class. So this is a 2.4 times improvement over the previous best of the previous best solutions in all those categories. Our runtime is about 30 seconds per class, as opposed to hours or days to actually run any of these baselines for one single class. For the user study, we have deployed this for programmers who use this for 1 week on code that they were very familiar, they were authors, so they knew whether those recommendations make sense. Triggered this tool over more than 1,000 classes code that they were familiar with, and of the recommendations for the classes where the tool gave a recommendation, they rated 83 of those as highly positive. And on average, they accepted 7 refactorings for users. So we know this because we have telemetry in the plugin that we use, so we could collect anonymously. We could collect how they use the tool. All right. Here's another one. It says, well, I was skeptical about AI, but I'm really happy. I think the qualitative service with people say, I'm really happy when you can do this, all this heavy lifting for me. All right, so here's a summary. This is the first end-to-end fully powered system that supports movement of refactorings. The key is that LLM plus the ID with the starting analysis plus the human in the loop. It's better than any of this on its own. So the secret sauce was combining the LLM, which does the creative part, which is akin to how human reason about code, with the ID for static validation, and with this search smart mechanism using retrieval augmented generation to be able to scale up and analyze very large projects. And this is where we came with these good results, better than the previous state of the art, and 1 to 2 orders of magnitude faster than the previous state of the art. All the data sets, all the benchmarks, all the tool, everything else is here. So our ongoing work, and this is where I'm going to find another gear, I'm going to shift to the next gear. It's on agentic approaches, and now we are using agents not to do one refactoring at a time, but to do several refactorings. So why is that the case? So take for example renames. When programmers perform renames in open source code bases, we notice that they don't tend to do one rename at a time, but they do a cluster of renames. So for example, they will start renaming a class, and then you'll say, well, this class has instance variables that instantiate this class, and then okay, they rename those. Then okay, well, this class we have to process, and we have to pass this class to some certain methods and functions who process and compute over this class, so they are going to rename those, update the names of those methods. And so well, those methods also have parameters that get passed into local variables. So it's very common that from one single refactoring, they start renaming a class and it triggers a chain reaction of several. And that's exactly the best case scenario for an agent, right? So agents are going to search and find all these program elements that have to be updated consistently and are going to invoke tools for us, and we're going to keep the programmer in the loop, so the programmer is always driving the design. Right, so here's some examples in IntelliJ. We looked at half of the commits contain these clusters of renames. Of this, the mean is like 3 renames per commit. The maximum is we found some commit that has 919 renames. These are distinct renames of different program elements in one single commit. Right? So that's what I want to have an agent help me to do that. I don't want to sit in front of the computer and do that by myself. Here's another one, Apache Flip, which is a famous open source project. The largest cluster had 243 renames in one single commit. All right, so this is what the developers told us when we asked them, when we deployed the survey, how painful this is, how much time it takes. They say that it takes on about 30 minutes or 30 minutes. Others report even on 45 minutes. There were other people. And these are not large. In this case, it's a 5. In this case, it's a server we deployed to a programmer who did 5. It was a cluster with 5 elements. So it took them 30 minutes. Again, why did that? It's not that these are bad programmers. These are very smart programmers. It took them 5 minutes because they actually had to think about all the related program elements. So scavenging and looking for all those related program elements and searching in different files. That's what took the majority of the time. Actually doing the refactoring, once you identify these are the elements that make sense to rename together, you can invoke IntelliJ and it takes 50 milliseconds for each of those names to go with IntelliJ. But it's searching and looking for that's what took the majority of the time. Alright, so I'm going to skip here. This is a multi-agentic solution. We have 3 agents working together to solve this. So one that actually infers and defines the programmer intent. The programmer starts by doing a seed, what we call a seed. We'll start doing one rename in the ID. That's all that we need. Once you rename that you do in the ID, we trigger this agent in the background. It uses that seed to see, okay, if they rename this, what else it makes sense to rename based on this particular seed. So this first agent will start and look and define the scope. It thinks, oh, this is what I think the programmer is trying to do. Again, the programmers here, as a reviewer, it's all the time in the middle of this design process. The programmer starts, and the programmer then is involved in the middle. This agent will trigger another agent, which creates a plan and will execute. Will show before they execute this. In fact, they are triggered and goes back to the programmer. I can validate and say yes, you're right. And it says yes, no, yes, no, yes. That's all I need to do. The agent keeps learning. There's an episodic memory where the agent keeps learning based on the selections that the programmer accepted or discarded. It refines back the scope, and then we have a third agent that replicates the same thing to other files. And this is one of the hardest things. Once you figure out in this file, this current file, what are the program elements, now those program elements switch into other files. So agent will invoke other tools, like invoke program analysis tools, and invoke the search engine, and will reach to other files, so it will do the same process. Again, this is very fresh work. In fact, we are sending the paper to Uppsala on October 10th, so next week my students are waiting for me to get home and help with the last final phases of helping them with writing and polishing the paper. But here are some of the incoming results. We run this on open source projects. This is 1.5 times better than the previous best in class. We compare again with vanilla LLM, with other agents that are not trained for effective generic agents. We are comparing with previous best in class state-of-the-art static analysis tools. This approach is 1.5 times better than the previous best of the best. And we submitted several patches to open source projects, and developers accept and say, they missed, they've done some of these clusters, we run our agent found more program elements that they missed, we sent a patch, and they accepted that patch. Alright, so I'm looking at the time, and I think I'm going to skip over this. There's another tool, there's some principles that we learned. Okay, let me very briefly go over this. This transplant was verified. One politician, and politicians can say whatever they want, but sometimes they say some good things. Sometimes they say things. It's like with the doctors, do what the doctor tells you, but don't do what the doctor does, or you have a saying like that. But this is actually a good one. Trust but verify. So it's the same approach like with the LLM. You cannot rely. You need to verify. You need to, if it tells you a recommendation, you need to verify. So for different refactorings, we've been working in this field now for 2.5 years. The rate of hallucination varies from, I talked about 80% for move methods, for extract method recommendations, 75% for unit test case generation, 35%. There's another one, Minecraft, which is a transformation by example, hallucination 65%. So you can't simply take the LLM solution. You need to develop critical skills. You need to look with a critical eye and say, does it make sense? What it makes sense? What are the flaws? How I'm going to eliminate those flaws and how I'm going to correct them. So in our case, we have these very powerful validators, alternative validators in the IDEs. We combine with the static analysis, we design new static analysis to validate, to look for all these hallucinations and discard the ones automatically. And let's see, here prompt engineering, so probably the biggest lesson here is the multi-size the prompt. You need to learn how to talk to the LLM. So if you just try to use an LLM to solve a problem, to give you some recommendations, you are not impressed with the original results, is that you need to learn how to talk in the same way when I come to Argentina, right? So when I go to a Parisha or something, I need to learn what are the, that's why I get this, right, to help me understand what are the best cards, you need to understand the culture, you need to, right? It's the same thing. You need to understand how to better communicate with them. Who wants to break the ice? Okay, we got here. First person. Is this on? Yes. Okay, good.
It is, okay. As the programs that will be replaced by those who don't know AI, are those who will replace the other ones still earn the same? Or do you expect as the productivity increase, the salaries also will increase?
So that's a very complex question. I couldn't tell you what's the economics of the people who use AI. They can write 50% more code, better code. How does that impact their salaries? Will companies say, well, now you do 50% more work than you've done 2 years ago, so I'm going to pay you 50% more? I'm not sure that will necessarily happen. But I can tell you the people who are not using AI cannot catch up. People will say, well, look at these other people, they write so much better code, faster code, they learn, they can explore so many more variants of the design space, and this is where I wish somebody will ask me a question of how do you use it as a student, how do you use AI to make you smarter? But those people who use AI to become smarter, those are the ones who are going to understand the technology faster, they can use more APIs, they can move faster than the people who are not using. So that's the one that I can assure you that those people who are not using AI will be replaced, unfortunately, by the ones who are using AI. It's the same thing like when we look previous generations, like when we moved from people who were writing low-level code to those people using high-level programming languages. Like you can write much better code in a high-level programming languages, right, than people who are using in bytecode and at that low level of representation. And then we had introduced libraries and frameworks. Again, with the library and framework, I can reuse code. I can do much better code faster, right? The people who had to write every single line of code and use this lower level of programming construct. So this is the next progression. It's not replacing people, it's asking people to engage with this technology and to move at the next level. And people who are resistant to it, unfortunately, they will not be able to catch up with the other people who are using that. So, but I'm not the CEO of the company, and I cannot give you an answer to your question on are we going to increase the salary by 50% if they write 50% more code. But I like your thinking, All right, what's the next question?
Thank you. I always when people say, "Oh, AI will replace your job," and I respond like, "Okay, start tomorrow." Like, please. But then when I use LLMs like ChatGPT or Claude, I have this tendency to know that they start sometimes really well and then degrade over the length of the session. And so when we talk about this like iterations on this agentic refactoring, have you seen those behaviors in your experiments? How do you catch those like degrading behaviors where the model is like, I don't know, getting negative feedback from something and getting worse and worse? And yeah, that's basically what's the field on that side that I noticed that is like pretty bad currently and actually makes things like kind of disappointing to use.
Yeah, that's an excellent question. ¿Cómo te llamas? Francisco?
Sí, Francisco.
This is a wonderful, wonderful question. So indeed, we noticed in our agentic AI, in the first iterations, we didn't have a human in the loop in the middle. We had a human at the end, and the agent will start working and it will start replicating some concept in other files. When it worked well. But the problem was when it didn't work, it started replicating some garbage and it got so quickly so off track that it was completely useless. Right? And that's when we realized, okay, at the end we are going to ask the human to review this work, but why wait until the end? Why not go actually in the middle, and the human could quickly catch, okay, oh, the agent picked up on some wrong concept, right? It will start renaming and start, because it didn't pick up on the right concept to rename, so it will start suggesting a bunch of variables and a bunch of that were not in the same clusters of renaming the program intended to do. So the quicker that you catch that and say, no, you're on the wrong track, so you say, no, that's when we introduce the human in the loop in the middle. It's not at the end, but it's actually in the middle of all this agentic loop. So that was one of the key elements, the key design elements that helped our agent to get rid of a lot of junk that it was generating. So the current agentic workflows, the ones who are really successful are the ones that incorporate some sort of a human element, not at the end where I've done all this work, and tell me is it good, up or down, but you can like have the human engaged in the middle of this agentic loop. So we discovered the hard way that that's a key design principle to have good quality solutions. Like especially like for those cases where in our case, the agent will invoke dozens and dozens of tools and will end up visiting hundreds of files. So in complex cases where you need to penetrate the code very deeply, it's very important that you catch the agent very early on, and you will say, I'm stopping you, I'm not letting you go on these tracks that are not productive. That's a spot on, that's a key design.
Hello, it's a pleasure to have you here. I'm using the translate because my English is not very good.
Okay? Your English is better than my Spanish. It's fine, you're doing great.
Well, I will continue with my college question. My question is this. I suppose there will be, as you say, the programmers that use AI will replace the programmers that don't use. But this will create also higher expectations on the code quality, on the code faster, so what will be the limits, right? I suppose there will always be demand for more quality, faster code. You think this will be measured for us, the programmers? Like there will be a limit, or there will be more always? You got my question?
So I understand the context, but maybe Ali, you can help me understand what is the question. I'm trying to understand what's the question.
So the question is,
Si va a haber un techo, siempre se va a pedir
if
más.
there's,
¿Cómo se va a llegar? ¿Se entiende?
Is there going to be a ceiling on the...
how will the programmers be qualified? If there's a limit of expectations that for the quality of what programmers create, because he think it's going to be always, as you say, change is the only constant, but we will need to get better always, or there is a limit to what we can accomplish.
Okay.
Yeah. Like what is the expectation for us? It always is getting improvement.
So the expectation is that you always get improvement. Yes. The expectation is like that's the beautiful thing about human mind. The human mind, it's the capacity we haven't reached our full capacity, and the beauty of the human mind is that you can always learn. We invent, we discover new things, right? That's why we are no longer don't see people. I mean, you still see people, riding the horses, which is beautiful. They do it for sport and for the beauty of it. But you don't, when I came here from my hotel from Marriott in downtown in Portland, I didn't ride the horse. I was very happy that I didn't have to ride the horse. Eduardo, the driver, gave me a ride. Right? So there's always progress. There's always. So as a humanity, this is what distinguishes us. That we can learn. We can become better. I don't think if you have the mindset that, I learned something 20 years ago and I'm going to do coding or programming the way I've done 20 years ago, then you're not going to be good in this field. So in this field, you have to learn new things, you have to relearn things, you have to also unlearn things. It's very important that we unlearn all ways of doing things and we keep adapting. So now in terms of productivity, whether I don't think that people are going to go and say, hey, I'm measuring, this is the expected productivity. I don't know, I'm making up some numbers. Let's say 129 lines of code, brand new lines of code per day. People are going to say, oh, this is the expected productivity, and I expect that if you cannot write 129 high quality new lines of code per day, you'll be fired. I think this is all going to be dependent on what's the code that you're working with, what's the culture, how clear are those requirements, how clear is your understanding. But I think the expectation is that you are able to, some people realize that after I finish the education from university, I don't stop learning, I keep learning. So you are what we call a lifelong learner, right? That's why, that's the expectation, that you're continuously to adapt and adopt new technologies. And people expect that, yes, the quality of the code, probably they will expect the quality of the code will get better. So there's a lot of research that shows that hasn't happened yet with AI. In fact, there's research that shows the opposite. They show that people who rely on AI without understanding, they are just like a code monkey. Like a monkey copies what the AI says and they don't understand. Like there's research that actually shows up that the quality of those code is not getting better, it's getting worse. And so they are not creating better quality, they are copy-pasting solutions that look deceptively similar to the correct solution, except they are wrong sometimes by 1 or 2 lines or by some small, simple variant. They are almost there, almost 80% correct, but they are not quite 80% correct. And that's the problem with the people who are not using AI to get smarter. They're using AI, they're just copy-pasting some solutions from AI without them understanding. Okay, is this the solution? Is this the right solution? Why is it the right solution? In what context is not the right solution? And so that's, unfortunately, we're going to see some of the code proliferating from those use cases. So that's probably the reason when you read some of the studies that show that the quality of the code is not necessarily increasing. That's why, because some people are not understanding the solution from AI, they just copy paste because that's the easy, lazy thing to do. All right, let's see.
Thank you for coming.
Federico,
yeah.
Sure.
Probably going back to one thing you said before, I think that someone learns from his mistakes. So that's a good tool to learn and think about that. And I was thinking, or I wanted to ask you, what's your take on the students using AI as a way to shortcut those mistakes. I think last week I told students in my class, this is the place to, during the class to make mistakes and talk to the lecturers or, assistants and learn what's the problem. And I don't know how mistakes that are tools for learning relate with this new technology.
That's a wonderful question. So thank you for asking that question. So I fully agree. The way how we learn as human beings, we learn a lot more from failure than from successes. Like success, it's a great motivator, but it's a really bad teacher. But success very rarely teaches us. Most of the things that we learn, if you think about from the young age, like I remember my children when they learn how to ride the bicycle. If you think how you learn how to ride the bicycle, you learn how to ride the bicycle because you started going and then you fell on the left and then you realize, oh, I have to. Then, if the biker wants to go more on the right, I have to slightly adjust my center of gravity on the left, and I have to have a certain speed. Like if I go too slow, I cannot have enough momentum. So it's all those failures that when we were children, we were not embarrassed to make mistakes. The biggest fear of the generation of students, what the sociologists call this, the Generation Z, so Generation Z, the generation after is coming, Generation Alpha. I'm Generation X. Some of the people here are the millennial generation, but most of the students are Generation Z. Now, people who scientists who study, you will say the biggest fear that you have Millennials have the biggest fear, the fear of missing out. They call it the FOMO. You have the fear of messing up. Right? So fear of messing up, the fear of messing up, FOMO, the fear of missing out, that's FOMO. That's what the previous generation had. Your generation is FOMO, fear of messing up, the fear of making a mistake. Why is that? So if you think about when I was your age, if I made a mistake, then probably it would be just mostly me and maybe one or two people who knew about that mistake. But now with social media, with everything, if you go to a cafeteria and let's say you take your food and you drop it down and people start laughing, and then people take their phones and start, taking a video and post on social media, and before you know, you and your 1,000 people at the university will have seen the video and all start laugh at you, how clumsy is the person. So it's things like that created this fear of messing up, the fear of mistakes. Like now, unfortunately, unless you embrace failure is your best teacher. Success, I say, it's a great motivator, but success is an awful teacher. Failure is the best teacher. And you have to embrace, everything that you learn by making a mistake, by owning the mistake, and by the cycle of success is these things. I try something new, I mess up, I make a mistake because it's new, it's pushing me out of my comfort zone. But then I just don't stay there and say, look at me, other people are smarter than me, other people, must be stupid, or must be unlucky, or what. You don't stay there and have pity on me by saying, well, I made a mistake, I'm not a mistake, I made a mistake. Right? I'm reflecting, what did I do wrong? What can I change? What can I do differently? Right? So try something new, I made a mistake, I failed. I reflect on it, then I get up from my failure, I fell down, I get up and I'm going back in the cycle. Okay, I'm going to try something else, right? And then go through this. This is the cycle of success. If you just make a mistake and stay there, or if you're not entering this because of the fear of messing up and you're not going through this cycle, you're not going to learn, you're not going to push you're not going to stretch yourself, you're not going to learn, you're not going to expand your mindset. So that's the biggest thing, you have to embrace failure, you have to embrace mistake. Now, okay, that's a more philosophical answer. Why mistake is the best teacher? Now, let me go back to the question that you asked about, is AI helping this short-circuiting or how can you use AI to complete this cycle of success? So some students can say, well, I'm afraid of turning in the wrong assignment, so therefore I want to get the perfect score. Therefore, I'm going to use AI, as here is the programming assignment that the professor sent me. I'm going to use AI. This is a lot true, especially in the beginner programming classes, but also can be in the advanced ones as well. But especially this is more important in the beginning, introductory classes. Because people are afraid of mistakes, they say, I'm going to use the AI, I'm going to generate the perfect solution, which very likely does. You turn that as the homework, and then you get the perfect grade. Now, the problem is you get perfect homeworks, but then when it comes to the final exam, you fail the final exam because you never understood, you short-circuited this cycle of, okay, I made a mistake, I got feedback. Well, I can get feedback from AI or I can get feedback from a human, it doesn't matter when you get the feedback. But that's important, that's when you learn something, when you wrestle with it, when you fight with it. If you look at the people who go and train in the Olympics, the people who push those weights that, I'm looking at them and say, how in the world like if I sat on their bar, they can push me, and maybe two more people like me, they can push and, or do a squat or something, right? Do they think that they got at that level in the Olympics where they can push and do hundreds of kilograms by training with, today I'm going to train, I'm going to do, this is a nice weight, how about I train with this? Like they do not train. Well, I probably, they started with a small weight, but it's wrestling, it's doing something that is hard, it's being uncomfortable, putting yourself in the situation where I'm no longer the smarter person in the room, somebody else is smarter than me, and I can learn from them, and I'm not embarrassed to go and tell them, hey, I made a mistake, or I'm stuck, help me to get unstuck. That's what really helps you, that's what really helps you grow. That's what breaks your day, that's what, in the muscles, the reason why the muscles grow, and again, if you look at me, and I should not talk about muscles because I'm not a muscular guy, but the people who go and exercise, they tell me that what makes the muscle grow is breaking of the fiber, breaking of the cells, it's that remaking, like that's the equivalent also for us, the same metaphor. It breaks the way how you think, it breaks the mold, it breaks the way how you look at the world, like before it helps you to revisit and look at it in the new light. So that takes courage, right? As Federico said, embracing failure and saying, okay, I'm not going to be embarrassed or afraid of making mistakes. It's making mistakes that helps us to push our boundaries, that helps us to discover better ways. Someone asked me earlier about, the human in the loop. Like, we make this mistake. We design agents without human in the loop in the middle of the process, right? We tried all those things. We failed so many times. And every time we came back and said, how can I tweak? How can I make this 1% better than before? Right? And that's when you go back in the cycle. I tried something, I failed, I reflect on it, I change something about it, I go back. That's the cycle of success. All right, so we have questions here, and I see people having questions in the back. Yes. What's your name?
Juliana.
Juliana, okay. What's the concept?
I have a question about when you talked about the moon method by the faculty by LLM. How did you measure the 80% hallucination? You take into account the extra code, or also you take into account about the modified code?
So we take it, so the question is, how do we count 80% hallucination rate? So we take the recommendation that was generated by LLM, and we try to actuate to execute that recommendation. So sometimes it's mechanically impossible. Sometimes the LLM says, move this code from this method to that other method. Well, you cannot move the code because maybe this method depends and calls a lot of the local variables from the local class. If you move the code somewhere else, it will not know those are private variables. So you cannot move this method because if the code will fail to compile. So we measure how many compilers we get, how many are infeasible and mechanically not possible solutions. It will tell you move this code from this method to a class that doesn't exist, that you can't even actuate. So we look, like for this recommendation for this class, we look at all the ones that the LLM said, and we quantify. Okay, this doesn't work, this doesn't work, this doesn't work, this doesn't work, for this reason, for that reason. Here is one that works. Right? So for every 10 recommendations, 8 didn't work for several reasons. 2 of them worked. So that. Good question. Yeah, so there's a question. Okay. So I think it was here in the back, and then I see over here, and then over there. Okay, good. Excellent.
Well, it's time for your presentation. I want to know if you have a special message for teachers, how to include this technology, AI, in the lectures, how they include in the students' materials, how the exercise, how they prepare all this stuff with AI.
Yeah, I think that's a wonderful question. I'm happy that you asked me that. So what recommendations I have for teachers? Now, I don't know what's the policy of your university. There are some universities who say, oh, you are forbidden, you cannot use AI at all, they can have some other extreme. There are some, well, there's no policy, you use it as much as you want, I don't care how you came up with the solution, as long as, so I don't know where in this continuum are you more like, we don't allow students to use it at all, or you say you can use as much as you want, or there's somewhere in the middle. I don't know how
we are discussing.
We are still discussing, okay. Okay, so I can tell you, the ones who have tried the extreme, you cannot use at all, you cannot enforce the policy because you cannot be a police officer, you cannot be at students' homes when they work on the homeworks. And so that thing, just by the nature of it, you cannot control, you cannot police. The other one, which so normally people go from one extreme to the other. Also, if you look in the political sphere, you see when one party changes, you see, okay, they went, the previous administration went that way, then they go to the other extreme, so you see people going from one extreme. So you see people either going to first extreme and realize quickly that you cannot control that, so they jump to the other extreme. Well, if you cannot control them, let students use as much as they want. You cannot control, you cannot enforce it anyway, let everyone use as much as they want. That doesn't work either, right? You quickly realize that students, if you don't teach them how to use it ethically and responsibly, they're not going to learn. And now we see students who started using it 2021, 22, so now 24, 25, it's the first generation that went through 4 years of education, and they're graduating, and they realize that they are not competitive, they cannot get entry-level jobs because they're not prepared to even get entry-level jobs. So they short-circuited their learning because they haven't used AI to let them to expand their thinking. So now I think the role of the teachers in this new era is to teach students how to use it in an ethical way. So I tell them, hey, you can use AI, but don't use it to stop thinking. Use it more as a thinking partner. Right? So if this is an assignment, then I can say, well, here is my first attempt. Then I write the code, and I go to AI and say, criticize this code. Tell me, be a thinking partner with me and tell me what's wrong with this code. What are some corner cases I haven't thought about? Or stress test with me. Give me some variants. Okay, I wrote this code to solve this problem, but now here are some conditions, like what are some examples of scenarios where this code maybe has to be more performant, or this code has to meet some other non-quality requirements. And how do I stress test? So now AI is a thinking partner with me. Now it hasn't replaced my thinking, now it augments my thinking. It has been covered very quickly. I wrote something myself that I understand, and I say, give me now variants of this. So I can very quickly explore 10 variants of the same solution. So this variant is better for this scenario, this variant. Now I use AI to teach me something, right? But I'm the author, I'm in the driver's seat. I'm in full control. Like if it gives me a variant, then I ask, explain to me why this variant is better for this circumstance, right? So that's the beauty of AI, that it can teach you things, it can cover gaps, but you need to stay, you need to wrestle. When they talk about the equivalent of someone training, you cannot say, well, I can solve this problem. If before I had to think about for 60 minutes, now I only put 25 seconds to write the prompt. Maybe I don't get it from the first time, it takes me 2 iterations and I get a solution. So I short circuit 60 minutes of thinking, and now I can get the same thing done in 2 minutes, and then I'm done. And I can go and watch Netflix. Now, if you do that way, of course it can be done. You get perfect grade on the form. You fail the exam. You finish 4 years, and you realize you are not able to pass the test that they give you when they hire you as an entry-level software engineer. So that's our role. How can we teach students, okay, here are some ethical ways that you can use AI to augment your thinking, to help you to be a better thinker, not to make you lazy, but to make you smarter. So I think we need to model to them. These are correct ways and these are incorrect ways. So I'm never taking too much, because I want to give an example in the graduate level of classes, how I use it.
We still have several questions.
Okay, good.
Okay.
So
You can talk later.
Let's go for like we don't lunch, right?
So
Right,
I'm going to try to translate.
Yes.
I speak English, but it's better for me to speak in Spanish.
Sí.
So, creo que esta discusión de si usamos inteligencia artificial para enseñar, yo soy matemática. En los años 70 fue la misma discusión si ingresábamos a las aulas permitiéndole al alumno usar la calculadora.
She's a mathematician, and so she remembered that in the 70s. The question was whether to let the students take the calculator to the class.
So, un buen matemático mundial decía que sí, pero el desafío que teníamos los que enseñábamos era enseñar a razonar y enseñar el fundamento de las operaciones que el estudiante tenía que realizar con la calculadora. El desafío es mucho más grande que enseñar una tabla de multiplicar o algo para dividir. Entonces uno tiene que enseñar a razonar para que el estudiante sea congruente con los datos que él ingresó. Entonces, y eso me parece es la discusión que estamos teniendo ahora, que vamos a tener que ser mucho más hábiles en la enseñanza e ir al fundamento de lo que estamos enseñando. para que después puedan ellos, por espíritu crítico, examinar si el resultado que le contestan es correcto o no. O sea que el desafío es mucho mayor.
Right. So she's saying that the challenge for us as teachers is higher now, as it was when the students were, using the calculator, because at that time, what they were talking about was that you need to teach the fundamentals and
preparations, because here in the student can criticize the result. You understand me?
So you need to teach not only when you use a calculator, right? Not only do you need to teach how to do a multiplication, you need to tell them the fundamentals so they can learn if the answer is the correct one, right? So they need to develop a critical mind. So, yeah, for us teachers, she's saying this is similar to what is happening now with AI.
Yes.
So we need to get better as teachers to explain how to get this critical mind.
Yes, I agree. So the critical thinking is the most important. Like that's a great analogy with the calculator, right? But before someone can use the calculator, like when I went to school and I had to do how to do multiplication table, I had to learn the multiplication table for the basic numbers, and then the ones with the paper I still had to learn how to do it. And then of course you can use with the calculator, 123 times 179. Of course I can do it a lot faster with the calculator than with. So it's the same thing.
I want to learn to ask you what type of logic are inside intelligent artificial? Because there are a lot of logics, not only the logic, the classical logic, and then is another type of logic when you program in this type of thing.
So
because there are logic of every, a lot of, como dicen,
Yo entendió tu pregunta.
¿entendió?
Sí, sí. Yeah, she's asking about what kind of logic is inside the LLMs.
Yes,
Yeah,
because
okay.
no solo la de los valores de verdad, sino hay la de Lukasiewicz, etcétera, se pueden estar metidas, y eso es lo que me interesaría, because I logic.
Yeah. So LLMs only work because of the huge amount of data they have seen. So they are not what people talk about artificial intelligence. They are not meeting the test of artificial intelligence. They are simply using statistical measures to say, here is the next token that it makes sense. In the sequence, this is the most logical token. Like here, they predict, okay, here I have two tokens, and this all started from the spell checking. It's a great example. People who write simple text, it's a great. They are saying, okay, if the first word is I love, then what are a sequence of words that make sense to come? So it's all based on statistics. It's all based on. They're looking at millions of phrases it contains the sequence I love.
Yes.
They're looking what's the next, what are plausible next elements that come after that, and they assign a statistical distribution for these words, and then they predict, and then they look at bigger context and say, it's I love, but it's in a paragraph, and if you use paragraph, you talk about dogs and talk about food, then it becomes more contextual. It's a lot more complex than just looking at the two tokens, right? That's where they build these very large models that have millions and millions and millions of parameters. So I'm not a researcher in the field. I don't invent. I don't make contributions. in the way how LLMs work. I'm a researcher in the field of software engineering. I can tell you a little bit about what are the logics. I can only infer. But somebody said, LLMs is just like it's a black box that the aliens came to Earth and drop a black box, and we're all playing with the buttons and trying to figure out how to discover. So what you see nowadays is a lot more like that. Lots of people are saying, here is a black box that the aliens brought to Earth, and we're all trying to figure out how to make it work, or what it can do for us, what it cannot do for us. So I know a little bit more of how they work internally, so based on those principles. I know this is areas where they are good at, or areas that they have struggled with, and this is what we compensate with other tools, with other static analysis, more established processes to compensate for what they have problems. Yeah, thank you. Okay, so I see hands coming up all the way. Okay, so I have the person in the back has been staying with the hand up.
The guy here.
Here. Okay, we have the microphone here. Then I promise the microphone will come to you. Okay.
Hey Danny, thanks for your talk. I've got a question related to maintaining large systems where AI-generated code is being used. As you said, some coding problem can be solved in multiple ways, and each of those solutions can be more complex than the others. But also, one of the use cases, as you said, AI is explaining that code. So I wonder whether that may make us programmers stop thinking about making the solutions simple, and that creating a loop of overly complex systems that may fall under its own complexity. And how can we tackle that? Because we are tending to stop making things simple, because AI is a tool right there for us to explain everything. So I wonder if that's a real challenge.
So I'm trying to understand from your question whether the challenge is that the tools produce something that is not explainable AI, and we take it just as a face value, or
yeah. What I'm saying is that by having AI, by being able to use AI to understand, to explain code for us, we as programmers tend to stop trying to make things simple, because then we can say, oh well, another programmer can also use AI to understand the code I'm writing, but for maintaining large systems that can create a complex loop.
Okay. So okay, I understand now. Perfect for the clarification. So you're saying, does it create actually the opposite effect, that we are saying, well, if I don't need, why should I care about writing the nicest, cleanest, more maintainable code when AI can explain even messy code to other people? So AI will be like a natural, like an interpreter or a translator, right? I say something gibberish or something, and then AI can help people understand. Like you say, is that going to create forces going in the opposite direction, that people feel less ownership and less say, why should I worry about? So that's an interesting approach. I'm thinking that similar, because of the laws of capitalism and the free markets, I'm thinking that that will not be the case. I hope that it will not be the case. Because people, so you mentioned, I think someone mentioned earlier, how can we use AI, I think it was somewhere in this, oh yeah, there's a person over there. He said, is it going to increase the quality of the code? And I think now, as we come with more tools, so for example, continuous integration and code reviews assisted by AI, so a large company, people spend an enormous amount of time in code reviews. Right? So now, with the help of AI, we can, of course, a lot of the code reviews are done by the human, augmented with AI. So there will be more code reviews, and there will be more rigorous reviewing of the code. So that code that doesn't meet a certain level will be criticized by AI, will be criticized by a human. So they will be the gatekeepers. In the code quality, in the companies that care about code quality, there will be more gatekeepers. Now you have both the human and the AI who can criticize and comment and give suggestions how to improve the code. So I hope that will drive the design in the opposite. Instead of people becoming sloppy, you can say, well, I can write that code and other people can use AI as an interpreter for me. It will be more gate checks and it will be more automated things done with the help of AI that will not let the code become sloppy, but will actually catch not only bugs that, oh, you're using a piece of code that is known to have some security vulnerabilities or is known to have some flaws, but it will be even at the design. You don't see yet so much people using AI at the design level to comment, and so AI hasn't been used yet. This is just the first, we are at the groundbreaking of the first, we have a project where we're using AI for code reviews from the point of view of doing the design. But I hope, and I think more and more people will adapt to this. It will not lower the standards, it will help the human get at the higher standards, so the code will be better and more designed and more refined. That's now, if I have a glass ball, if I can look through that and predict the future, I could tell you that if I'm right or wrong, but that's from what I hope and from how I do research. I want to go in this direction.